Okay, welcome back everyone to Grockit's OGTV. This is the GMAT edition. We're going through the 12th edition of the guide to the test. As it says in the lower left portion of your screen, you're on Grockit right now in case the URL or the rest of the browser didn't indicate that to you. My name's Jim Jacobson. This is me up here sitting by a giant spoon with a giant artificial cherry in it. You probably can't tell that from the picture, but that's what's going on there. And last time we left off with, we finished with question 133 on page 177 in the problem solving section of the quantitative section. So we're going to pick up with question 134 on page 171. So 171, question 134. Our answer choices are 3/2 by 7/2. 5/3 by 10/3, 2/4, 3/6, and 10/3 by 20/3. Okay, a certain rectangular window is twice as long as it is wide. If its perimeter is 10 feet, then its dimensions in feet are what? I shall draw a rectangle for your measuring pleasure. This is not drawn to scale, although I guess that might actually be twice as long as it is wide. Okay, so for this, we aren't given the actual dimensions of the rectangle, we are given the relative dimensions of the rectangle, but that's good enough because algebra can get us the rest of the way. We know that the width is x. I guess it could have been w, but I called it x. It's too late to change it. And since it is twice as long as it is wide, the length is 2x. Remember, the perimeter is the sum of all four sides. 2, 3, 4. So the perimeter would be x plus 2x plus another x plus another 2x. And that equaled 10. So, we add that up. That ends up being 6x equals 10. X equals, that's a 10. 10/6. X equals 5/3. Of course, we were actually asked for the dimensions of the thing. Now, of course, only one answer choice has 5/3 in it. That's answer choice B right here. But let's just make sure we're right. If the width, that's x, is 5/3, 2x, 5/3 times 2/1. 5/3, 5/3 times 2/1, which is the same thing as multiplying it times 2, that equals 10/3. So 2x equals 5/3 times 2 equals 10/3. So 5/3 by 10/3, answer choice B, is our correct answer. And we can then safely move on to question number 135. Still on 171, of course. Okay, so we have 6, 7, 12, 14, 17. 6, 7, 12, 14, 17. So the diagram above shows the various paths along which a mouse can travel from point X, where it is released, to point Y, where it is rewarded with a food pellet. So this story has a happy ending. How many different paths from X to Y can the mouse take if it goes directly from X to Y without retracing any point along a path? I shall attempt to recapture this drawing because it matters a little bit. So we have basically a diamond, we have another diamond, and we have a third diamond. And really the size doesn't matter. We're interested in the number of points between them. So that's a point, that's a point. And then we have that. And then this, there's Y. Here's X. I guess I don't really need to draw the points on here because we're not adding number of points it can pass, we're just adding number of paths it can pass. How many different paths can it go? So and we'll just number these, junction number 1, junction number 2, and junction number 3. So at the first junction here, first fork in the road for our little mouse on its way to its cheese meal, it can go one of two ways, the top way or the bottom way. Okay, at the second junction, the second fork in the road as the mouse proceeds, it can go two ways. On this one, on 3, it's tempting to kind of read something into it, how it could somehow go, up here, then down here, then over here, then over here, then over here. But it's not supposed to retrace its steps along any path. It's always supposed to go forward. So we don't actually count that as a separate way. There are, in fact, only 3 ways it can go. It can go the top way, it can go straight, or it can go the bottom way. So there are 3 ways there. So to figure out the total number of choices, for every so it can go 3 ways at the end, and for each of the 2 ways before that, it could go each of those 3 ways. So this is 3 ways down here, and for each of those 3, it could go one of these 2 ways. So it could go 1 1 1 2 1 3. So we have to multiply those 2 together. And the same then is true of the first choice, that for every combination of one way from here and one way from here, it could go one of the 2 ways here, we also have to multiply this by 2. So 2 ways times 2 ways times 2 ways, 2 times 2 times 3 equals 12. There are 12 different paths for our mouse to go on its way to delicious cheese. Answer choice C is the correct answer. Okay, number 36. We have, 136. Page 171, number 136. We have 30, 60, 90, 30 times the square root of 15, and 60 times the square root of 15. I suppose I don't actually have to read the answer choices out loud to you since I'm printing them on the screen, and the GMAT doesn't have them orally, but I have to keep the answer choices in my head from the time I glance over at the book to the time I glance back to the screen. So they're a little insight into the nature of international web broadcasts. If the operation symbol, and it doesn't really matter what the symbol looks like, but it's it's one of these symbol questions. If the operation symbol is defined by x symbol y equals the square root of x times y, for all positive numbers x and y, then the quantity 5 symbol 45, and then again symbol 60 equals what? So we know that x, this thing, give it there. We know that. And we're trying to solve for 5, 45, 60. And again, don't get distracted with what the symbols look like. It never matters. As long as it's not multiplication, division, addition, subtraction, or some kind of radical sign, the symbol is irrelevant. You need to get your mind around just substituting the numbers that you're given into the definition of that operation. So our first one then is, so whatever's on the left side of the symbol and whatever's on the right side of the symbol are multiplied together, and we take the square root thereof. So this first one, because we always do parentheses first, remember our order of operations tells us that parentheses, that's what the P stands for, those come first. So we do this one first. So that is the same thing as 5 times 45. And that looks like it would be pretty unpleasant, and it would. But the thing to remember that's useful about exponents, and this is something that's totally your friend throughout the GMAT, is that the square root of xy is the same thing as the square root of x times the square root of y. Also, that within this multiplication unit here, within the xy, you can reconfigure, if, for example, let's just use the real numbers that we have, 5 times 45, it helps often to break these down into their prime factors, because then you can often find the squares of prime factors in this operation and take them out from under the radical sign. What do I mean? I mean that 5 times 45 is the same thing as 5 times 5 times 9. and that's a much more comfortable thing because 5 times 5 is, of course, 25. So we have the square root of 25 times the square root of 9, which is the same thing as the square root of 25 times the square root of 9, and these are our buddies. These are squares that you should know. This is the same thing as 5 times 3, which is 15. So we know that this expression here, within the parentheses, this equals 15. We then, of course, have to do it again with 60 this time. So we now have the square root of x, and in this case here is 15. The y value is 60. That was the value after the symbol. And once again, it helps to break them down into their prime factors so we can look for pairs and look for squares. So 15 is 3 times 5. And 60 is, well, we could say it's 15 times 4. And we can break that down even more. We can leave the 4 as it is because that's already a perfect square, so we don't have to do anything with that. But we can see then that it's 3 times 5 times 3 times 5 times 4, which is the same thing then as, I probably don't need to do this intermediate step, but I want to make it clear for people who have more trouble, who have less recent experience with these exponents. 3 times 3 is 9, so we have a 9 in there, we have a 25 in there, and we have a 4. Those can be separated out. We have the square root of 9 times square root of 25 times square root of 4, which then gives us 3 times 5 times 2. 5 times 2 is 10, times 3 is 30. Answer choice A gets us more points on the GMAT. The big thing about these symbol questions that usually throws people off, and the reason they keep putting them on the GMAT, it's not usually that they're very challenging, although I would say that the multiple dealing with kind of complicated expressions under the radical sign makes this one harder than many. But a lot of times people just freeze up because they don't know what to do with these. If you kind of ignore what the symbol is and just plug things in exactly the way that they have them, match up the numbers, you know, x is 5, y is 45, you know, match it up and you should have no trouble at all with most of these, you know, formula or, you know, substitution questions. Okay. We are now on number 137 on 171. So we have 0, 0.12 repeating, 1.2, 10, and 12. So a bar over a sequence of digits in a decimal indicates that the sequence repeats indefinitely. What is the value of 10 to the 4th minus 10 squared times 0.0012 with the 1, 2 repeating? A fine question. 10 to the 4th minus 10 squared times 0.0012 repeating. So of course you can't easily subtract exponents from exponents. You can multiply, divide, and raise exponents to exponents, but subtracting them you would actually have to figure out what those numbers really are and subtract them. There are easier ways of handling this problem. Basically, because each of these is a power of 10, and when we multiply, you know, this times this minus this times this, each of them is going to move the decimal point further to the right. So I think we want to do that rather than actually figuring out what 10 to the 4th minus 10 squared equals. So when we distribute this out, we end up with 10 to the 4th times 0.0012 minus 10 squared times 0.0012. Repeating. Okay, so 10 to the 4th times this means we move the decimal place 4 to the right. 1, 2, 3, 4. So that's going to be 12.12. Remember the 1, 2 repeats. So it's 12.12 repeating. Minus 10 squared means we move it 2 to the right. 1, 2. So this just equals 0.12 repeating. The neat thing about this now is because we're subtracting the entire repeating part of the decimal. So, 12.12, no matter how long this goes on, dot, 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 go on, give me the dots. There we go. This one goes on that same amount, and we can subtract the whole thing. So 12.12 repeating minus that 0.12 repeating just leaves us with good old 12, which is answer choice E. We win. Okay, moving on then to number 138. Last one on page 171 in case you were sick of it. Okay, we have 1/2, 2/5, 3/5, 4/5, and 5/8. Okay. At a loading dock, each worker on the night crew loaded 3/4 as many boxes as each worker on the day crew. If the night crew has 4/5 as many workers as the day crew, what fraction of all the boxes loaded by the two crews did the day crew load? This one's challenging for a lot of people. I've actually been asked about this one a number of times. It helps to think about this as a rate question, or at least it helps me to think about it as a rate question. So if we multiply the number of workers times the number of boxes per worker, the rate at which they load boxes, that equals the number of boxes that they did. And really, the day crew is the standard by which the night crew is compared. So, if the day crew has one worker, which doesn't really work in terms of the numbers, but if the day crew has one worker, the night crew has 4/5 of a worker. So first we want to figure out what the night crew actually is. So they have, according to the question, 4/5 as many workers, and they load 3/4 as many boxes as each worker. So their boxes per worker is at a rate of 3/4. So their total rate, their total boxes compared to the boxes of the day crew are, we multiply across, numerator and denominator. We can, of course, cancel out the 4s. So we get, this is the night crew, equals the night crew fraction of day. But that's not actually what the question is asking. The question is then asking what fraction of the total number of boxes does the day crew add? So let's figure out what the total boxes are. So if the day crew adds, or does, they do 1, that's the number by which, or to which we were comparing the night crew. They do 5/5 of a load. The night crew only does 3/5, as we just determined, but we add the two together, so the two of them together get 8/5 of whatever, a job done between day and night. And so then the question is, what fraction of 8/5 is what the day crew does? So we can simply do, they do 5/5, the ratio of that to 8/5. We can multiply, this whole thing times 5/5, and what that does, it gets rid of the denominators in both cases, and we are left with 5/8. So the day shift does 5/8 of all of the work between the two crews. But, they have more guys, and they also have daylight to work with, which is apparently why I just made that up, that's why they get more boxes done per worker. But anyway, day crew, 5/8 of the total. We move on to page 172. Okay, so 172, number 139. So we have 40, 42, 39, and 41, 38 and 40, 37 and 39, and then 36 and 37. On the real GMAT, I definitely do not recommend, unless it turns out to be extraordinarily helpful for you, I do not recommend writing out all the answer choices again. It is useful to write out A, B, C, D, E so you can cross off answers you've eliminated, but actually writing this out is something we're doing just for the purposes of a broadcast. So a restaurant meal costs $35.50 and there was no tax. If the tip was more than 10%, but less than 15% of the cost of the meal, then the total amount paid must have been between what and what. So that's why each of the answer choices has two values. We are determining the minimum and the maximum possible values of the meal with tip. And we don't know what the tip was. So that meal was $35.50. And since we know that it must have been more than a 10% tip but less than a 15% tip, if we figure out what a 10% tip would be and what a 15% tip would be, we then know what the numbers are between. So let's make this the 10% and we'll make this the 15%. So over here we have our 35.50. 10% of 35.50 is just 355. 10% you can just move the decimal point over one. So we add 355 to the price. We get 39.05. So then we have to do the same thing over here with our 15%. 35.50 and 15%. I actually had to multiply this one out because I couldn't do it in my head. 35.50 with a 1.15% increase, you get big numbers. And then we have to add all the decimal points, 1, 2, 3, 4. So it ends up being $40 and let's just say 83 cents. So rounding it up, and then the only answer choice that's close to our answers here is then total amount paid must have been between that, so it's answer choice B. Okay. Moving my book over. Okay, 172. Number 140. Okay, 225, 275, 325, 350, and 400. So in a weightlifting competition, the total weight of Joe's 2 lifts was 750 pounds. If twice the weight of his first lift was 300 pounds more than the weight of his second lift, what was the weight in pounds of his first lift? So this is a very familiar question type on the GMAT, the 2 equations, 2 variables. We have 2 lifts that Joe has. We'll call F the first one, and S, that fateful variable, the second one. I probably should have come up with something else because, again, S can look like a 5, but we'll just be careful. So we know from the one equation that his first and his second have a total of 750 pounds. We also know that twice the weight of his first lift was 300 pounds more than the weight of his second lift. His second one, sorry, twice the weight of his first one, so 2F, was 300 more than the weight of his second one. So if we subtract 300, then that equals his second one. Because, 2F equaled S plus 300, we can subtract 300 from both sides to get 2F minus 300 equals S. And the reason we want to do this here is we want to substitute this value for S into the equation, the first equation that we have, so that we can solve for F, because F is actually the value that the question is asking for. So F plus S equals 750, so then F is this, plus, and then S is this one here, 2F minus 300. That equals 750, so that's 3F minus 300 equals 750. 3F equals 1050, and then F equals 350. Choice D. Joe can lift a lot more than I can, as it turns out. Anyway, moving on. 172, number 141. 43, 44, 49, 50, and 51. So a club collected exactly $599 from its members. If each member contributed at least $12, what is the greatest number of members that the club could have? So in order for it to be the greatest possible, so we have $599, let's get that down there, and each of them contributed minimum 12. Now, the club with the smallest number of members would have one person who contributed $599 all by him or herself. So the converse of that is that to have the largest number of members, they all need to have contributed the smallest number possible, and they all contributed $12 minimum. So the largest possible number of members has each of them contributing exactly $12, or whatever that is closest to $599. So we'll call N the number of members. So $12 times that large number of members needs to be less than or equal to $599. Now it doesn't look like $599 is going to be evenly divisible by 12, so that means that at least one member will have contributed an odd number of dollars, but we still want N to be the largest number possible. So we just divide $599 by 12. Four times 12 is 48. 119. So the $599 divided by 12 gives us 49 and 11/12. So then we know n is less than or equal to 49 and 11/12. And so that's really where this trap, this is the trap right here, these two numbers. So if you're trying to say, if you forget that n actually needs to be less than this, because we can't go over $599, you might have chosen 50, saying, well, that's almost 50, we can't have partial people, but we really do need to round down. So it actually needs to be 49. 49 people in this club. Enter choice C. Okay. 172, number 142. We have 2, 5, 6, 7, and 14. So if y is the smallest positive integer such that 3,150 multiplied by y is the square of an integer, then y must be what? Which sounds a little bit intimidating. So what it's saying is that 3,150 times y equals a perfect square. Or it's the square of an integer. So as we were doing in that question just a little bit ago, remember when you have, some big radical sign and you have all these numbers, blah, 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 x, y, z, a, b, that in order for the whole thing to be a perfect square, we need to have even pairs of the prime factors. So if there are 2 3's in here, that's going to be a 9, which we can take out as the square root of 9, which then puts a 3 outside the radical sign. So we want 3,150y to be something like that, where it's all, 2 times 2 and 5 times 5, that all of its prime factors match up. And we don't know what y is, so we need to figure out what y is. And y is going to be the number that adds in whatever prime factors are missing from 3,150. Let me show you what I'm talking about. So let's actually start doing this prime factorization of 3,150. So we're doing 3,150y. The first one to notice is that this is 10 times 315. So this is the same thing as 10 times 315 times y. The y kind of doesn't matter for the next little bit, which is the same thing as 10 times 3 times 105. 315 is the same thing as 3 times 105. And now we're starting to get to some prime factors. 10 we can also break down, and 105 we can break down. So this is 5 times 2 times 3. 105 we have to do more with. 105 is 5 times 21. And then that's the last one that we have to get the prime factors out of. 5 times 2 times 3 times 5. And 21 is, of course, 3 times 7. And remember, there's a y, under there too. We're just not dealing with it right now. So in order for this whole thing to be a perfect square, which is what we need to figure out what y is, all of these need to be pairs of prime factors. So we have a pair of 3's, we have a pair of 5's, but what we're missing is we're missing a pair for the 7, and we're missing a pair for the 2. So in order for all of these to have a pair, y equals 2 times 7. So that if y equals 2 times 7 here, then we have a pair for the 2's and a pair for the 7's, and the whole thing ends up being an even square root with no radical remainder. So y equals 2 times 7. Y equals 14. Answer choice E. And we move on to the next column on page 172. 3, 4, 5, 6, 7. So this is kind of a symbol question. So if putting brackets around x is the greatest integer less than or equal to x, what is the value of brackets around negative 1.6 plus brackets around 3.4 plus brackets around 2.7? So we have negative 1.6 plus 3.4 plus, what was it, 2.7? 2.7. So remember, we need the greatest integer less than or equal to x. It's easy with the positive numbers. The greatest integer less than or equal to 2.7 is plain old 2. The greatest integer less than or equal to 3.4 is 3. Because in order to be, less than this, we have to just cut off the decimals. The trick, of course, is with this one. The number less than negative 1.6. Less means more negative on the number line. So this one actually, rather than chopping off the decimal, we need to go up to the next highest decimal to get the smaller number. Negative numbers are smaller the bigger the number is. Negative 3 is less than negative 2, and in this case, negative 2 is less than negative 1.6. So the three of these together, the 2's cancel out. 2 and negative 2, we are left with 3. Answer choice A. Okay, 172, question 144. We have negative 4, negative 1, 0, 1, and 2. So if the quantity 4 minus x over the quantity 2 plus x equals x, what is the value of x squared plus 3x minus 4? So we have 4 minus x over 2 plus x, and that equals x. Well, I think the first thing we want to do is get rid of this fraction here, so we would multiply both sides by 2 plus x. So we would get 4 minus x on the left, and then we would get 2x plus x squared on the other side. So then we want to get everything, we want to get all the x's, all the numbers on one side. So we would subtract 4 and add an x to both sides to make this over here go away. So we would have x squared because there weren't x squared terms on both sides. We had 2x here, we were going to add one more x to it. And then to get the 4 over here, we need to subtract 4 from both sides. So we get x squared plus 3x minus 4 equals 0. Amusingly enough, the question actually asked us, what is the value of x squared plus 3x minus 4? So we can smile and say, yay, because this one actually, in simplifying the given expression, we went ahead and directly answered the question that they were asking. So x squared plus 3x minus 4 equals 0, answer choice C. Okay. 145 on 172. So we have 39, 40, 42, 45, and 46.5. So the trapezoid shown in the figure above represents a cross-section of the rudder of a ship. If the distance from A to B is 13 feet, what is the area of the cross-section of the rudder in square feet? So probably calls for a picture. So we have A, B. We know that this is 5 and this is 2. And then we have some kind of line from A to B, which I'm not going to bother to make a dotted line. You can handle it, I think. And we learned that the distance from A to B is 13 feet. So we have that. So we're trying to find the total area of the trapezoid. The important thing to know here is that there's an actual formula for the area of a trapezoid, which really is a matter of breaking it down into two triangles, but you know, the formula shortens things up a little. So the area of the trapezoid here is going to be 1/2, 1 base, base 1, plus base 2, times the height. And we know what the values of both of the bases are. That's the 5 and the 2 here. The bases are the lines that are parallel. The other lines of a trapezoid are not necessarily parallel, because if they were parallel, we would call it a parallelogram rather than a trapezoid. So 1/2 base 1 plus base 2 all times the height. And so in terms of the stuff that we know so far, that equals 1/2 base 1 we'll call 2, base 2 we'll call, jumping ahead, 5 times h. So the area is going to be 1/2 of 7 times whatever the height is. And the height here is going to be this distance. The distance of the bottom of what ends up being a triangle within the trapezoid. And there's two ways you can go about this one. We'll do the long way first. Since this is a right triangle, we can use the Pythagorean theorem. The square of the hypotenuse equals the sum of the squares of the other two sides. So 5 squared, one of the sides of the triangle, plus, we'll call it h, because it's going to be the height of our formula here, plus h squared is going to equal 13 squared. It does help to be familiar with your square roots and your squares of numbers up through 15. So this is 25 plus h squared equals, that's an equals 169. Subtract 25 from both sides. H squared equals 144. We recognize that immediately as the square of 12. So h equals 12. Yes, h could have been a negative number. When you square, take the square root of a variable, or the square root of a squared thing, it could be negative. But since we're dealing with actual distances here, you can always discard negative values for those. So h equals 12. And we can fill this in the rest of the way. A equals 1/2 of 7 times the height of 12. 1/2 of 12 is 6, so 7 times 6 equals 42. Choice C. I mentioned there was a fast way to this. There are what are called Pythagorean triplets, numbers where the perfect squares always work out, and one of them, or where the ratios of the sides always work out, and one of them is 5, 12, 13. The more common one is the 3, 4, 5 triangle, but 5, 12, 13 is another one that if you have spare brain space, you can commit that to memory, so that triangles with sides of ratios 5, 12, 13, or multiples of 5, 12, and 13, you can figure out the third value if you recognize two of the numbers. Anyway, answer choice C is our correct answer. Okay, so last one on page 172, number 146. And our answers are 2.5, 3.125, 4, 5, and 6.75. Okay, in a certain sequence, the term xn is given by the formula that number is 2 times xn minus 1 minus 1/2 of xn minus 2 for all values of where n is greater than or equal to 2. If x sub 0 is 3 and x sub 1 is 2, what is the value of x sub 3? And so really what this is saying is that for, in the numbers in a sequence, any given number is the value of 2 times the number before it minus 1/2 the number before that. We probably need to keep track of all these different x values. So we're trying to find x, the third one in the sequence. And so that one's going to equal 2 times x, the second one in the sequence, minus 1/2 of the number 2 numbers before that, which is x1. Now we don't actually know what x sub 2 is in this one, so we actually have to figure that out. So let's do that one first. X sub 2 is then going to equal 2 times the one before it minus 1/2 the one before that. And we can fill in the numbers we know. So we know that x sub 1 from the problem is 2. 2 times 2. And we know that x sub 0 is 3. So minus 1/2 of 3. So this is 4 minus 3/2, or 1.5. 4 minus 1.5. Since the answers are in decimals, we may as well move to decimals right away. So x sub 2 equals 2.5. We now have all the values we need to solve this guy up here. So make a little bit more room. So this is 2 times 2.5. Come on, give me, there. Minus 1/2 of, and then remember x sub 1 is 2, so 1/2 of 2. So 2 times 2.5 is 5. 1/2 of 2 is 1. So it equals 4. Answer choice C. Okay, let's move on to the next page. Page 173, question 147. We have 10 minus 5 times the square root of 3. 10 minus 5 times the square root of 2. 2 and 1/2, and then 4. So in the figure above, V represents an observation point at one end of a pool. From V, an object that is actually located on the bottom of the pool at point R appears to be at point S. If VR equals 10 feet, what is the distance RS in feet between the actual position and the perceived position of the object? Picture time. Since they have a picture, it's not always in my best interest to draw a picture, but I think on this one it's important because we need to draw lines that don't actually appear in the diagram. So we have V up here, we have R about there, and S there. And the line isn't straight, but we shall pretend it was, and by drawing that right angle symbol there. So this thing, V to this, I'm going to call this the origin, even though it's just kind of like the bottom edge of the pool. So OV, or VO, is 5 feet, and then OS, this whole distance, is 10 feet. We're given that by the problem. And what it wants to know is the distance between R and S, and we need lines here from VR, and then another one to VS. So that turned out pretty well. Okay, So, since these are right triangles, we can use our buddy, the Pythagorean theorem. And one of the things that's going to help us a little bit here is realizing that VO plus OR, or VO squared, this distance here, plus this distance here will equal the hypotenuse of this particular triangle. Yeah. Oh, sorry, VR equals 10 feet also. I knew I was forgetting something. VR equals 10 feet. So we can figure out what OR is using the Pythagorean theorem. So that's, we're using VO squared plus OR squared is going to equal VR squared. And we know two of those three numbers. So 25 plus OR squared equals 100. OR squared equals 75. So then the square root of 75, OR, I should do this out here, square root of 75, that's the same thing as the square root of 25 times 3, and we can take the square root out of this, so that equals 5 times the square root of 3. So this distance here, OR, is 5 times the square root of 3. And the question was then, what is the distance from R to S? So if we were to subtract OS minus the length of OR, we will get RS. So RS, we know the value of OS is 10 from the original drawing, 10. And we know the value of OR now is 5 times the square root of 3. And that looks exactly like answer choice A, 10 minus 5 times the square root of 3. So we win. Okay. I think we will try to do this next one. And this is going to be the last one because this one's relatively complicated. Page 173, number 148. And our choices are 10, 12, 15, 18, and 30. Okay, so if x, y, and k are positive numbers such that the quantity x over x plus y times 10 plus the quantity y over x plus y times 20 equals k, and x is less than y, which of the following could be the value of k? Let's write all that out first. So we have x over x plus y times 10 plus y over x plus y, times 20, and all of that equals k. So this problem is a big exercise in making things, grouping like things together and making things look more alike. We can kind of simplify these individual elements, and we will get 10x over x plus y plus 20y over x plus y equals k. And so we can condense that all into a single fraction, because now that they have a common denominator, we can do that. So 10x plus 20y over x plus y equals k. So from there, we kind of need to do a little unpacking of this. We can factor out the x plus y element. So this is the same thing as 10x plus 10y plus another 10y. So the numerator is, so because this is, there are two 10y's and one 10x, so we can say this is, didn't mean to scribble that, 10 times x plus y plus 10y over x plus y. And then we can break it down again into two fractions because we have the two separate things. We have 10 times x plus y over the quantity x plus y. And we can add that then to 10y over x plus y. And you can see why we did this now, no pun intended on the word y. In separating out this x plus y here, this cancels out. So we're left with 10 plus 10y over x plus y. We're still not there though. Remember then, we need to make the denominator look more familiar in terms of our actual question here. So we know that x is less than y. We can also then say that x plus y, which is the denominator of our fraction, x plus y must be less than 2y because y is less than x. If y and x were equal, it would be equal to 2y, but since x is somehow less, this is less than 2y, but still greater than y itself. And now that we have this x plus y in the middle here, we can try and make the whole thing, we're trying to convert the second half of our original expression into something that looks more like a number. So we can do reciprocals of all of these, because x plus y is in the denominator. And when you do reciprocals, the relationship between all the numbers changes. So it actually ends up being 1 over y is the greatest of the numbers. We're kind of switching directions here. We have 1 over x plus y. And then this is 1 over 2y. And if we can, put a 10y in the numerators of all of these, it makes our life easier, again, because we're trying to make it look like this guy here. So 10y over 2. So we're multiplying every answer by 10y here in our inequality string. And then you can see that we can actually cancel out the y's from these end terms. So that's just 10 over 2, which is 5. This one's just 10. So this expression, 10y over x plus y, is less than 10. Oh, x plus y, sorry. Is less than 10 and more than 5. And remember then that and k equals this thing here plus 10, because we have this 10 over here. So 10, running out of room here, 10 plus 10y over x plus y is between 20. Adding 10 to both of these is between 15 and 20. The only answer choice that is between 15 and 20 is answer choice D. So just in the nick of time, I finished the hour. Next time, so my name is Jim Jacobson. You've been listening to me talk you through some problems. Next time, we'll pick up with question 149, the second column on page 173. And yeah, hope to see you then. You've been listening to Grockit's OGTV, the GMAT edition, 12th edition of the guide.